All right. Hello, everybody. What's going on? Hope you're having a wonderful day so far. Welcome back to the channel. Welcome back to the stream. Today is May 6, 2025, and we're back teaching us some Python, learning Python once again. I hope you are having a wonderful day so far. Welcome, welcome, welcome. Hey, Musa, how's it going? Welcome in. All right, you guys. Let's go ahead and pull up the Discord real quick and say, all right. All right, everybody. What's going on? I hope you're having a wonderful day so far. Welcome in. Mr. Tim, we gotta have a discussion, dude. Let's discuss what should we do next. And we need to hold an investigation because just worked up and got your video, buddy. Just worked up and got your video, buddy. What you mean, Musa? I have no idea. I can't decode that one. Tim, what's going on, dude? So for one, we need to have an investigation. What happened to Mahan? Bro disappeared. Bro quit on the stream, I think. I think he's done. He's gone, bro. Anyone heard from Mahan? He was mad that I wasn't doing his leak codes and he just bailed. Secondly, we need to discuss, you guys. Hey, Marty, what's going on, dude? Welcome back. We need to discuss what to do next. Oh, just woke up. It's crazy how spelling does that. Completely changed the sentence. Hey, yeah, so what should we do next, you guys? We just released our chromaplot.com, which is a full stack application that utilizes a scientific, concept and serves generated data plots based upon, an experimental simulation, which is really, really cool. So if you haven't checked that out, go ahead and visit chromaplot.com. I will be warned that I am only on the free version of the host I'm using for the server, so it's really, really slow to return the item. So just put in the data you want and then go away for about a minute and come back and it'll probably be there. It might fail because it might, auto kick it out if it doesn't return back the data from the server in time. But it's just really slow to do the generation, the processing speed of the server that currently I'm doing just a free version of render.com. So it's super, super slow. But it's just for learning purposes, but go ahead and check that out. I also have the code on my GitHub, and it is within the Discord link down below. I made a part of the open source section, so you guys can go ahead and make a fork of it and try to make a pull request if you want to contribute or improve the algorithm or any sort of ways. You can go ahead and do so, and then we can merge that into main, and it'll go live on the site. It'll auto render onto the site. Yeah, I was confused with sitting there for 5 minutes. Time for a wellness check on Mahan. Yeah, for real. He didn't respond to my message in chat. Well, when I added him, I said, "Where are you at? Where are you at? How long have you been learning to code?" I started 3 months ago. Nice, dude. That's awesome. What you been learning and how you like it so far? I've been been teaching myself for about 11 months now. Coming up on the 1 year mark. So that's what we need to discuss, you guys. We need to figure out what is next. Like, what do we want to do next? What do we want to build next? What do we want to work on next? What is next for us, you guys? What would you guys like me to build? You guys have anything in mind? You know, anything that you think would be a good project or a challenge? JavaScript? Ugh. JavaScript. I was hoping to avoid that one. I don't know. Dude, if it has curly braces in the language, I don't want to do it. The MERN stack. M. What does M stand for? I don't know. E. I don't know. R would be Rust, maybe? N. Don't know. Do we want to do math? Should we start doing math courses and getting into math? Or do we want to do we want to build like a site, like at least like just quickly put together like a personal site so we can start, you know, getting job applications ready? Like that's what I was thinking. Language is up. Force of JavaScript. Oh my goodness. Can I solve it in Python? Interviewer, could I solve it in Python, please? This doesn't look like Python. I'm kind of at a standstill, you guys. I don't know really what to do next. Like, we were watching the Panda videos on Corey Schaefer, but I kind of stopped watching those. We got to number 4 here. We could watch another one of those to start off here. Why don't you do a simple RAG? What's a RAG? Let's look at some job descriptions and go off that. Hey, Insomniac, how's it going, dude? Should we look up some job descriptions? What should I look up? Bioinformatics jobs. Hold on. How do you do this without like choosing a location? Okay. Let's see here. It's super easy. You don't need a lot of Python to do it. Basically, custom knowledge chatbot. Python. I'm vibe coding it. I'm clearing up a lot of tech debt on a personal project. Nice, dude. All right, let's see here. Associate LM LIMS Bioinformatics Engineer. So work extensively with cloud-based star LIMS. Develop or modify existing code using star LIMS scripting. So once this is LIMS. What is LIMS? Not a good start. Should we do our next site in React, Tim? Should we try to learn React? All right. Workflows, troubleshoot, encounter process in public, RESTful APIs, charts, dashboards, 5 years experience using formal programming languages. Dude, I'm screwed, bro. Bachelor's degree required. Master's or PhD preferred. It's over, bro. It's over. Prenatal. What the heck? Bachelor's of Science or Master in Bioinformatics, Computational Biology, Computer Science, or Bioengineering. 1 to 2 years of biology research, either experience. Strong programming skills in Python. This is not bad. This one's not bad. This one's not bad. Should we save this one? Develop sophisticated robotics next generation analyst pipelines under the guidance of senior scientists. Cool. Analysis of clinical bioinformatics data. What do you think about this one, Tim? Oh boy. Read something. What was the chroma plot about? Something like this. Research scientists process plot the raw data extracted from scientific instruments. Kind of. What you mean, Insomniac? Yeah, dude, learn Reactor View. You learn one of them, you learn them all basically. LIMS is probably some tech step stuff, not gonna lie. Like when a company specifically lists stuff like that, you know they're tech debt. You don't need degrees for that stuff either, trust me. It's some crap their creators said the job description. Okay. There's hope out there then. Let's go like one more page here. Analyst 1 through 2. See, these ones aren't terrible, but just a 6-month stint contract role. This one says the importance of the role, genomic and data science projects, collaborate, maintain software solutions and support R&D, joining them with data sets and APIs. Bachelor of Science with 4 years hands-on experience in biotech. Okay, not bad. We're about on that cuff. Applied knowledge of software design patterns, data model. Yep. Chromaplot.com, baby. Boom. Check. GitLab. Deploying to cloud. Use GitHub. Okay, cool. Python. Got you. APIs to Django's Flask Fast API. Check. SQL. I've done one project in SQLite, so I probably need some more experience with some database stuff, for sure. Nah, whatever that is. Yes. Yeah, yes, web-based data visualization frameworks in Python. Chromaplot.com. This one's not terrible. Not bad. Just gaming the system, put keywords in. They can't really verify the information until they actually interview, so not as much. Most companies just offload a broken system. Yeah, this is the Chroma plot. We'll have to, it'll take forever to load. We'll have to come back and wait for it to load. Alright, it'll take forever to load here. We'll come back to it. This one. I gotta get my, we gotta do a resume day. My resume is not good, guys. It's not good. Like I get denied from every single job application I send out, even ones I'm qualified for. So it's clearly like my resume is trash. So we'll have to have a resume day. Okay. So what is next, you guys? Let's go ahead and do a poll here. I'm sorry, guys. This is gonna be on YouTube. All right, here we go. All right, the poll's up. Yeah, Eduardo, that's what we're trying to think about right now. We were just literally just saying, like, should we do that? I own the the domain michaeldeming.com. So like that's what we need to. That's what I think was going to be our next project here. So I have that in the poll here as an option. So go vote in the poll if you are interested in it. In my opinion, PySide/RawQt is better choice because the Qt is actually a C++ library and you can translate Python Qt apps to their raw C/C++ equivalent more easily. My resume is asked at the moment too. Man, I know that feeling. About a year ago, I tried to move out from front end to machine learning engineer. Then, due to life changes, I'm forced back into front end, and my stuff is all over the place at the moment. That's personal projects I'm working on. Dude, it's crazy. Oh, let's go check on the plot. Oh, okay, here it is. So, right, you have when you do this is a thin layer chromatography. So, you would basically plot compounds on an axis, on the x-axis, and then you dip it in a salt. You dip the overall solid phase in a mobile phase, which is a a solvent, and that solvent through various forces will travel up through the medium and drag basically these compounds with it, uh, and they move at various rates. And as you can see, these rates are put in here by this factor, this retention factor here. And so in the lab, what you would do as like a chemistry student is you would do this experiment, and then you would do the math actually of this height divided by the overall height to get the ratio of its speed relative to the solvent. So I'm basically just modeling that here. And so we put this to a full front end framework here with Fast API, Python, HTML, JavaScript, and CSS. Pretty cool. We finished that up yesterday, so if you want to see more about that, check out yesterday's stream. You plan on developing... Do they have career counselors at like your old schools that you can go back and talk to, Tim? You plan on developing something around ChromaPlot? I mean, yes, definitely we could keep going on this and continue to add, chemistry simulations of various sorts or calculators to do chemistry related calculations, acid base, chemical balancing, all those types of things, redox reactions. I can definitely incorporate in here. I'd have to refresh up on some of my general chemistry, but we can definitely throw those in here and model other things. I think would be cool to model. We could potentially maybe use like C or Python to uh, like model like heat maps to create like the chroma graphs for the like what are they called? Basically, like each element has a distinct like light wave, and you can see that when you do stick something to it. And I forgot. I had to look up that exact lab that it's where you do that one. I remember stuff like KC, KP, PKA, yeah, all that kind of stuff. Um, Let me get caught up on the chats here. As Svelt, how do you pronounce that? Svelt? Why are these names always so terrible? Is better than React, my opinion. Who uses this? Researchers? I think just students, really. Educators, students. I'm sure any uni will accept alumni for career counseling. Hello. They would hate to say that their alumni graduated from their school and didn't get a job. Yeah, my school says they will support you and help their alumni for life. I assume USU is the same. Oh, interesting. I didn't know that. I can send you a link in Discord on your DM. It's about something you can think about, like a L Corp session slides of people working on similar projects. And these schools want to see their alumni succeed, obviously. You ever have days where you sat down and your brain could not code? I swear I tried 3 to 4 times to get a coding session and it could not do it. Yeah, dude, definitely. Having one of those right now. What projects do you suggest for OOP based? Like inventory things are really good for that, in my opinion. Like just like creating some sort of object that you track in like an inventory system and then logging that in a file and then reading that back and creating the objects back is a really good like quick little thing to do. All right, well, I don't, honestly, guys, I don't know where to go from here. I'm kind of at a loss on what to learn next. Let's see what the poll says. People say math, science, NumPy, and pandas. People want us to keep going with that. So should we watch the next Corey Schaefer video? That's the next step here. Kind of want to have like a fun like day though. I want to kind of like watch like a YouTube video with you guys and like we released a project, like we deserve like a little wind down, I think. Like, you know what I mean? Let's see here. Is there like a coding video that we can like react to and watch together or something? Let's see here. Let's see. Anybody got something we should watch? Let's look up like intermediate programming. What should we watch? Any of these? Intermediate literature trap? What the heck? Um, I saw this one. This one's guy's crazy. He did a C compiler interview in the McDonald's. Isn't this that guy that does those funny things? Math. So people think we should go and keep going in math. So should we watch a pandas after this then? Should we watch one chill video and then watch pandas? Is there some sort of video? Is there a video we should watch? Hey, what's up, No Good Nick? How's it going? I like that name, No Good Nick. It sounds like one of those old like books you read back in elementary school. I think the project we just released yesterday, I didn't even write the README. So OF is calling me out. Why is your name OF, by the way? I gotta know that one. Let's watch this.
Computers make no sense. Throw some metal in a box and boom. What the heck is going on here? Inside your PC is a central processing unit or CPU. It's basically just a piece of silicon with billions of microscopic switches called transistors. Depending on the flow of electricity, they can be on or off, kind of like a light bulb, which gives us two states, 1 and 0. The value at one of these switches is called a bit. One bit by itself doesn't really do much, but put them together and a group of 8 bits is called a byte and can have 256 different combinations of zeros and ones. Congratulations! We can now store information by counting in a system called binary. Every bit represents a power of 2, 1 meaning the power is included and 0 meaning it's not. So this number has 1 times 64, 1 times 4, and 1 times 1, which adds up to 69. This is nice, but for humans, hexadecimal is even better. It's often denoted by the 0x and is simply a more
What am I
readable
doing? I
format
don't
than
even know. What are we doing, you guys? All right. time to, what are we doing? Time to get back into the grind here. What are we doing? Okay. So let's keep going here. Filtering here, number 4.
So we're going to go over the basics of filtering data from data frames and series objects. So for example, if we wanted to look at our survey data and only look at people who...
Okay, why are you doing this to me? There you go. Yeah, we got to study, you guys. Like, I am an Eli. That was live from yesterday as well. Oh, what's up, dude? To connect to OFans. Gentlemen, please. Send you a Discord. Alright, I'll check it out, man. Okay, alright, let's get into this. Let's keep going here. We got to keep going on our pandas. Pandas. Okay. So we want to... This is from episode 3. So let's go here. Jupyter Lab. Okay. Give me that. Let's go here. Let's create a new thing. Alright. Let's go. Let's go.
Python, then we can filter that data out. Or maybe we only want to see results from a specific country or people that have a specific salary range, anything like that. We can do all of that by filtering out data from our series and data frame objects, and we'll learn how to do that in this video. So filtering is one of the main things to learn with pandas because it's basically how we begin every project, by filtering the data that we want from the data that we don't. Now, I'd also like to mention that we do have a sponsor for this video, and that is Brilliant.org. So I'd really like to thank Brilliant for sponsoring this series, and it would be great if you all could check them out using the link in the description section below and support the sponsors. And I'll talk more about their services in just a bit. So with that said, let's go ahead and get started. Okay, so first of all, let me show you something that's going to be the basis for our filters. If we perform some basic comparisons using our data frames, then we'll get back some interesting results. So let's see what this looks like. So right,
gonna do OF. We'll do in some. Okay, and we'll do those in a list. Now we'll do last, right? This will be no good, Nick. This is gonna be Tiny Tim. We all know Tim Tiny. Niak. You like that I go raw, bro? Chill, 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 chill. Whoa, 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 whoa. We are getting way too friendly on this channel lately, you guys. You guys are funny. All right, we're gonna import pandas as PD. We're going to say our data frame is equal to a pandas pd.dataframe class object, and we're going to use that and create it off of our current people dictionary. We'll then call df, and that will show our 3 people there. Cool. Let's get back into the course shaper video here.
now I have my snippets notebook open that we've seen a couple of times throughout the series, and at the bottom here, I'm going to make a basic comparison and see what the result looks like. So let's say that I wanted everyone that has the last name of Doe from our data frame. There should be 2 since we have a Jane Doe and a John Doe here in our data frame. So in our bottom cell here, I'm going to put a comparison that says df, and then we want to access that last name column. And now we can just say if that last name equals Doe. So if I run this, then what we get back is a series object. And this might not be what you expected. So maybe you thought we would just get a data frame back with all of the values that met our criteria. But what we got back is a
Okay,
series
so all the
with a bunch of
booleans
true-false
of
values.
those.
Now,
Got
these
you.
true-false values actually correspond to our original data frame. And the true values are the rows that met our filter criteria, and the false values are the rows that didn't meet our filter criteria. So you can basically think of this like a mask. So we can see here up here in our simple data frame, the last name of Schaefer is false, and these two last names here with Doe are true. So this is a filter mask and when you apply it to a data frame, it will give you all of the rows that meet that filter criteria. So now let's apply this filter to our data frame. So first, I'm going to assign this, this returned series here to a variable. And I'm just going to call this variable filt. So I'll say filt is equal to, and then this comparison here. Now, filter is a built-in Python keyword, so be sure to use something else. Anytime I assign these to variables, I usually just use this filt keyword here, or not keyword, but variable name. Now, I also
Is this
usually
not
like
Jupyter
to wrap
Notebooks?
my entire filter in parentheses because I find it easier to read. So this isn't going to change anything, but I'm just going to put this entire thing here within parentheses so that I can see that this assignment here is separate from this equal sign. Okay, so now we have this filter here. And remember that this filt variable here is equal to this series here of true and false values. And now let's apply this filter to our data frame. And we can do this in a couple of ways. So you might see some people do it like this. We can just pass that directly in, like we are searching for a column. We can pass in a filter there. And if I run this, oops, and I got an error there because I did not run this cell to set that variable. So I'll rerun that. And now if I run this, then now we can see that we get a data frame back where it returned all of the rows that have the last name of Doe.
Okay.
Now, we only assigned the filter on a different line because I think that's easier to read, but you might see some people put these comparisons directly in the brackets for the data frame. So you might see something like this. So I'm just going to comment that out right now and just grab this entire filter here. You might see some people do it like
put
this.
it right in
just
there.
Paste it or put it directly in there. And we can see that that works too. Now, I think that that's a little more difficult to read than just assigning this to a variable. So I'm just going to use that as a variable, but you should know that it is a possibility since you will see some people put the filter directly in there. Okay, so that's one way of narrowing down those rows. Now, another way that you can do this, and the way that I prefer to do it, is to use the .loc indexer that we've seen a few times now. And I'll talk a bit about why I prefer this in a second, but if we pass in that series of booleans into .loc, then it should give us the same results that we currently have. So if I say df.loc and pass in that same filter, then we can see that we get the exact same thing. This here gave us the same results as our .loc down here. So this is one reason why pandas can be a bit confusing to people, because there are multiple things that you can pass into these different brackets to get different results. So like I said before, .loc is used to look up rows and columns by label, but if you pass in a series of booleans like we did here, then you can also filter data out. Now, the reason that I like using .loc for this is because we can still grab the specific columns that we want as well. So for example, if I wanted the email column, then I could simply say, pass in a second value here into .loc and just say that we want that email column. If I run that, then we can see that we get the emails that match those last names. So remember, the first value to .loc are the rows that we want, and the second value here are the columns that we want. So since I wanted the email column, it gives me a series of those emails where the last name is equal to Doe.
And the filter
Okay,
is
so
equal
real quick,
to
let's go over some other ways to filter data out here. So first, let's go over the and or operators. Now, we can't use the Python built-in and or keywords for our filters, so we're going to be using some other symbols. And the symbols that we're going to use here are the ampersand for and. Let me write these out here. The ampersand for an and this vertical bar for an or. So these symbols carry over from other programming conventions, so you may have seen them before. So for example, let's say that we wanted our filter to get all of the rows where the last name is Doe and the first name is John, which should only return this one result. So in order to do this, we can go back up to our filter here, and I'm just going to get rid of this cell here because I'm just going to be using .loc from now on. So now with our filter here, let's say that we want a last name equal to Doe, and, which we're going to use the ampersand, and we want the first name equal to John. So I will put that in here. And I also, let me actually separate these out as well. I like to have each one wrapped in parentheses. I think it makes it a bit easier to read. So now if I rerun that filter and then rerun our .loc, then we can see that now we're just getting that single email address. And that email, again, is where all of the last names were equal to Doe and the first names were equal to John. So in this case, it's just one result. So now let's look at an example using the OR operator. Now for this, we can use the vertical bar character. So let's say that I wanted a filter where the last name is equal to Schaefer or the first name is equal to John. Okay, so if I wanted the last name to be equal to Schaefer or the first name is equal to John, for the OR, we're going to do a vertical bar character there. So now, if I rerun this, then we can see that we get back all of the rows or all the email addresses where the last name is equal to Schaefer or the first name is equal to John. So in this case, it was these two rows here.
Gotcha.
Now we can also get the opposite of a filter. So let's say that I wanted to get the complete opposite of this filter where we want all of the rows where the last name isn't Schaefer and the first name isn't John. Now I could go in here and fiddle around with this query that I currently have, trying to get everything right, or I could simply add in a tilde at the beginning of this filter, and it will give me everything that didn't match that filter. So if I just come in here and put a tilde there, then that is going to negate that filter and give me the opposite of those results.
Is this not just Jupyter Notebook?
Jane Doe, because that is all the results where the last name was not Schaefer or the first name wasn't John. So this goes back to truth tables that some of us may have studied in school. Now, if anyone is unfamiliar with truth tables, then let me know, and maybe I can make a future video.
Jupyter Notebook, simpler interface, focus on one notebook at a time, great for beginners. Prefers notebooks, tab and split view, plug-in rich system, better for large projects.
On that subject, but it's more mathematical related than programming related, although the two do overlap very frequently. Okay, so that kind of covers the basics of filtering on a small data frame, but now let's go back to our larger data set of survey data and look at some real-world examples of some filters that we might want to take a look at. So I'm going to bring up my other notebook here, and here we have the Stack Overflow survey data that we've been using throughout the series. And again, if you'd like to follow along, then you can find a link to this code and the data in the description section below. Okay, so
I'm going to go here. To my previous file. I'm going to get these real quick. There. And then so they also add in here a index column equal to quote respondent, and they add in an index column quote 85 df head. I might not have that index respondent invalid. Let me just set this then. And then this one doesn't have it either. So hold on. So let me set it to response ID, right? Like so. So now that's response ID, and now we'll go here and do schema df.head. Okay, so now we'll give it to I wanted to column. I'll say index column equal to, we'll say it's equal to the QID, I guess, for a lack of anything better. Okay. Nice. All right, let's keep going.
Now that we've learned about some basic filtering, let's see if we can
Hey,
run some
Brayon, how's it
filters
going?
on our survey data here. So for example, let's say that we wanted to look at the data for people who are making a salary over a certain amount.
Original tripping.
Now maybe we want to take a look at what languages are earning the higher salaries or something like that. So in order to do that, I'm going to first create a filter. Now, if you don't know which column in the data frame gives the salary, then you can always find that using the schema data frame that we've seen throughout the series that tells us what each of these columns here means. But for the sake of time here, I'll just tell you that the column for salary, if I go over here, I think I can find it here pretty quick. It is this converted comp right here. So if we scroll down through some of these survey results, we can see that this person says that they make about 9,000. This person makes 61,000, and these are converted to USD. And real quick, let me reload this page here just to make sure that I have run all of these cells and that I'm that all of these variables here have been
total.
Think you need a dev team and a big budget to launch your Microsoftware as a service ID?
No!
Wrong. All you need.
Goodbye.
Initialize. Okay, so if we wanted to get a filter with all of the high salaries, then let me come over here and again, I will copy this column name here. And now let's make a filter. And I'll call this filter.
Okay, so I'm going to do comp total filt is equal to, we're going to say df index comp total equal to or we'll say is greater than like, what does you want, like 50,000?
High salary. And I'll set this equal to a conditional here where we're saying that we want the df of this converted comp column of our data frame. We want that to be over, let's say a high salary is over 70,000. You know, this is kind of subjective, but we'll do that.
People are struggling out here.
And now let's apply that filter to our data frame. So just like we saw,
okay, we got it right.
I can say df.loc, and I can pass in that high salary filter there. And now we can see that we get some results here. And this isn't all of our respondents. We can see that now it's respondent 6 and 9 and 13. So if I scroll over to our converted comp, then all of these salaries here should be over 70,000, and it looks like they are. Now, in order to narrow these columns down a bit, let's just grab a certain number of columns. So I'll grab the country, the programming languages, and the salary. So to do this, remember we can just pass these into .loc. So up here where we're
whoa, is that? No, that's comma. Yo, oh, rupee. Yo, it had me there for a second. Who took this salary? This is yeah, rupee. I thought that was USD. 85 euros, 110 USD, 126 420 Great British pounds. 95,000 Great British pounds. These are top 5 salaries. Greater than 50,000.
I'll put in a comma here, and now I'll put in a list for the columns that we want. And let's say that we want to get the country. We also want to get the programming languages that these people have worked with. And this here, and like I said, you can look all of these up in the schema, but this is under languages worked with. We can see that this person knows Java, R, SQL, and so on. So I'll paste that in as one of the columns that we want. And also I will get the converted comp. So I will paste that in as well.
Okay, so we got... Oh, so we also need their comp. There we go. So these are the top. This is guys. So these are some younger guy here, older guy here.
And now let's run that. Now we can see that we get not only the people who meet this high salary standard filter that we set, but also we're only getting the country, the languages that they know, and their salary. So our filter does seem like it is being applied correctly, and that this is working nice. So now that I'm actually seeing the countries here, that reminds me that we might want to do some filtering with multiple values. So for example, my YouTube audience comes mainly from the United States, India, the United Kingdom, Germany, and Canada. Well, that's where the largest percentages of the audience of people who are watching the videos come from. So let's say that I wanted to filter out
This
survey
Ruby
results
is
here
like
so that I only see the results from
thousandth
those 5
of a
countries
cent.
that I mentioned. Now, I could create a super long filter up here where I say, if the country is equal to the United States, or if the country is equal to India, or if the country is equal to the United Kingdom, but that would take up a lot of space. Instead, let's just create a list of those countries, and then I'll show you a neat trick that we can do to filter those out. So now up here, instead of using this high salary filter here, I'm just going to make a list of countries here, and I'll set this equal to, I'm kind of a slow typer here, so let me type these out really quick. Okay, so now if we want all of the survey results where the respondents said that they were from one of these 5 countries, then
Oh, you go DF countries in countries.
I can simply say, I'll set a new filter here. Actually, let me do that up here. I'll set a new filter, and I'll set this equal to DF
Would you say
country.
countries
So,
in countries?
where the country dot is in.
Is in.
And we want the country to be in this list of countries here.
Oh, okay. So then you can go like this. So now we can say, age, filt. Right. So now if I just go DF, if I just print DF here, remote work, hobby, I want some information. Okay, so we'll do this. We'll do languages. Right, is equal to a list, and we'll put in here Python, C, C++, and Java, we'll say, okay? And then we'll go language work with. So now we take this and we'll make a filter here called lang filt is equal to, we'll say this is df quote language work with dot is in, we'll pass in the languages here. right? And so then if we call now, we do that, and now we call df lang filt, we get this. Now if I call lang filt with just the age, the response ID, age, and then what is it, the language worked with. Language worked with length. Type error. Let me just get rid of this. Let me just say Python. Let me take this error and see what's happening here. Oh my gosh, come on.
So I'm going to run that cell. And now, let's
Oh my gosh, come on. Let's put that in there. You can type index value dependent because it's not how you're trying to filter. You're passing a tuple to df, which is not a valid syntax for standard. A single argument. df.loc. Oh, .loc. Response ID, not an index. Not an index. Trying to access column name response type, but doesn't actually exist in the data frame's columns. Data frame df columns. Language filter, response ID. It's right here though. Let me get rid of this then. Whatever. Oh, that is the index, so we'll get it no matter what. That's why. Okay. So 832 rows of people that only work with Python.
apply that filter to our data frame. So if I run this, and just to narrow down these results to make sure to where we can see the country right off the bat. I'm just going to only grab the country there. So if I run this, then we can see, okay, we get United Kingdom, United States, Canada, India. So it looks like that applied correctly as well. Now let me show you one more common filter operation that you'll probably use a lot. So we can actually use string methods within Pandas as well to do some alterations to our data frame, or in this case, to help with a conditional. So let me show you what I mean. So let's say that we only want to look at people who answered that they knew Python as a programming language. So let's see how we do this. So first of all, the column that lists the programming languages that each person said that they know is that language worked with column. So let's see what this looks like. So in this here, I'm just going to grab that language worked with column. Oops, and I spelled language wrong. So language worked with, is that right? Yep, okay. So we can see that we get some programming languages here, and each different language is separated by a semicolon. So we can't just do a query where we say, you know, if the language worked with equals Python, because the actual value of that column will be any combination of the languages listed on the survey. So one way that we could do this is to instead use a string method and see if Python is within this string of these languages that they know. So to do this, I'm going to rewrite my filter here. And I'm just going to say that my filter is going to be equal to, and we want to grab the languages worked with for each person, and then we're going to use some string methods. So I'm going to say .str .contains, and then I will pass in Python. Now also we can see that we have some NaN values here, but not a number. Now we need to also set a fill value for those, or else we're going to probably get an error. So that is part of the contains method here. I can just say NA is equal to false. We're just not going to do anything with those. So let me explain this one more time here. So this filter that we're putting in place here, it's saying, okay, for this column here, the languages worked with, which are all of these results here, we are saying the string in that column, does it contain Python? So that's my filter. I'm going to run that cell. And now let's apply that filter to our data frame by saying .loc
language have worked with. Okay, so now I'll do df.loc lang filt. And now we get that. Where now all these guys, now if we give in just this parameter here, there we go. Now those are those with Python.
And I will pass in that filter. And now let's also just grab the languages worked with column to make sure that that worked correctly. So if I run that, then all of these results here, or all of these rows that it gave us back, should have Python in their languages known. So we can see that we have Python there, there, there. So yes, it does seem to be in all of these results. Now this one here, number 8, we can't actually see it here, but we have these ellipses here. So it's probably just being truncated here. Now in my last video, I kept saying that these were being concatenated. I meant truncated. A few people pointed that out in the comments. So yeah, these are being truncated here. So we just can't see the Python value there, but they are there. And
check this out. I'm going to show you how I afforded this car.
Oh
okay, you
my
ready?
gosh.
All right,
And I'll probably do a complete video on string methods here in the future, since there's so much more that we can do with these.
What's up, Butler? How's it going? What's going on, Ray?
Text, to split values, and all kinds of different stuff. So it's these string methods are extremely useful in Pandas. So that's a basic overview of doing some filters with our data frames. Again, the key takeaways are that we can do these conditionals here and have them as a filter. And again, let me print out just the filter without applying it to the data frame. We can see that the filters return a series of true-false values. And when we apply that to our data frame, those true-false values basically apply a mask to our data frames where we get all of the true values back and not the false. So if I look down here, we have respondent 1, 2, 4, and 5 as true, and 3 was false. So if I look at my data frame here, we can see that we get 1, 2, 4, and 5, and 3 is not there because that value was false. So that's how filters work, and again, it's an essential part of Pandas because this is one of the first things that we do with our data whenever we are loading it into Pandas. Okay, so before we end here, I would like to mention that we do have a sponsor for this video.
I'll let
and
his
that is
sponsor play because we
Brilliant.org.
watch the videos.
Brilliant is a problem-solving website that helps you understand underlying concepts by actively working through guided lessons. And Brilliant would be an excellent way to supplement what you learn here with their hands-on courses. They have some excellent courses and lessons on data science that do a deep dive on how to think about and analyze data correctly. So if you're watching my Panda series because you're getting into the data science field, then I would highly recommend also checking out Brilliant and seeing what other data science skills you can learn. They even use Python in their statistics course and will quiz you on how to correctly analyze the data within the language. Their guided lessons will challenge you, but you'll also have the ability to get hints or even solutions if you need them. It's really tailored towards understanding the material. So to support my channel and learn more about Brilliant, you can go to brilliant.org/CMS to sign up for.
All right, cool. All right. Nice. Nice. All right, so that is our notes so far in our Jupyter lab here regarding this. So let's go here and to rename this. Control C. Rename 4. There we go. Awesome. That was part 4 of Corey Schaefer's series on pandas. That was a good video on filters. It was actually pretty easy. We just have to use this type of syntax where you just do for is the key value basically or the column value equal to that specific value. If it is, then it'll give us back a kind of like Boolean representation of each object for each row. Is that filter true or false? And then you can apply that filter to the actual data frame to get back those individual rows that it applies to as true for that filter. And then you can specify additional parameters to narrow it down even further, the data, not only not only all of the data, but just the first name column of the response back. We can use the ands or operators here in pandas to specify and filters or filters, pretty easy. And then we can use conditionals, greater than or less than. We can use a list to detect if is in for the filters to be within a list of filters, or also we can use a string method, so just stir contains to have be like, okay, does it contain this specific word, and have anything else in it doesn't really matter, just the specific word of Python, and then we'll ignore the NAs. So that's pretty that's a great overview so far. We'll watch the next one tomorrow. Sweet, you guys. So we put up a poll. We were at 52% math, science, pandas, NumPy, etc. 32% front end, with a total of 31 votes on the poll. So we'll go ahead and end that poll. Just continuing on with our data science wins here. So we'll continue on with this panda series. We'll watch a video a day. I have I don't know if it's like ADHD or something, but I have a really hard time finishing things. I'll get really close to the end and then I'll just stop in a lot of different things. It's I have this thing in terms of think of a bottle of soda. I'll drink it to the last quarter inch and then I won't drink anymore. I don't know what it is, but even in my projects here, in my books, I get to the last couple of chapters, the last couple of videos. So on ProGit, we have 2 chapters left and I have to finish the book and I haven't done it yet. And so I gotta get better at finishing my projects and finishing stuff. But on my coding projects, we're good at getting those done. Data science hype. Hey, we got to think of a project then for data science related. What kind of project can you do with data science? We did a chroma plot which used data in a way, but it didn't interpret data in a specific way. It just visualized a mathematical model. But what ways can we use data science to what if we could we not do a heat map? That's what I'm thinking of. What if we had a matrix of certain values, right? And you can kind of like what about this? Like for agricultural, like this is the first thing that comes to my mind. Like when I was in college, I took um, a plant disease and parasite course. It was a pretty tough class. It was my senior year of college. It was a parasites, plant biology, parasites, and something, or I can't remember. And it was a lot of foreign material regarding plants that I didn't know about, and having to learn about all that kind of jazz. Now, what if we did this? What if we did like a square footage, like heat map or something, like where we have like a n by n matrix where each cell is given a distinct value based on like activity, right? So, like, how many times was it visited by, insects or parasites, or so it could be tripped by monitors um, or by, or something. We could something, I don't know, sensors like, uh, and then basically what you could do is you could intensify the grade of color within that cell or that pixel, right? And then you could identify hot zones within your crop for like potential areas and of to identify as needing to like as like hot areas that are potential like causes for spread. Heat, temp, humidity. Yeah, we could do a factor of a calculation, right? So what if we do this? Ooh, I like that. So what if we have this? What if we have an n by n matrix? Think about like an n by n matrix, right? Where each cell will be an algorithm, right? We'll have an algorithm run within each cell to get a value between some sort of range of x to y. Now, that algorithm will be a some sort of mathematic value we'll have to determine based upon heat, temperature, and humidity. So like let's say like temperature outside, humidity, light intensity, right? Because it could be hot, but it could be, um, or I guess that's heat, right, Marty? So like it could be in the shade or in the sun at direct times. And then what you could do is that would be like a single instance in time, right? And then you could layer these frames over the top of one another, let's say a frame every minute to generate 60 frames to show you over the course of this hour time frame while the sun is moving across. It'll show you the travel of the sun through the heat as the sun moves to its position across the matrix. It'll also show you the impacts as the sun moves against the humidity, the temperature, and potentially like we could give like an activity factor of like you could even oh, all right, let's be adults. What do you guys think about that? So we have some sort of algorithm run to determine a value, to determine the intensity of some various colors, and then that'll determine the overall shade of the cell. And then, as it would, what do you guys think? I think I have something. I helped a friend who's doing in his master's in CS. I think I have a notebook. Okay. So like, think about it like this, where you have a matrix, right, that is just determining, that just houses basically like pixels almost. Like we're just generating like an image, right? Which is just like a matrix of pixels. So if that's the case, then what if we use some variables like humidity, temperature, and heat or light intensity, right, to formulate a a value of x for this entire cell. That x value would determine the pigment or shade of this cell, and then you could map basically simulations across the matrix as like the sun moves from east to west or west to east or whatnot, or various directions. um, right, let's say you have a breeze come in which lowers the heat slightly of the surrounding cells. You could see that happen. Right. So like let's say like, oh, you have, let's run a simulation of a gust of wind from northwest to southeast, right? So this way. Um, well, then all the impacted cells in that range would be have a factor, impacted by them according to the direction of this, you know, um, wind, uh, to lower their heat. And you could see that the shade kind of like actually cool across the plane. Crazy idea, huh? Just popped in my head right now. Heat map plotting, yeah. Something like that. How would you know which variable is being affected? I mean, I don't know. That's the thing is we're just coming up with ideas of projects here. What's our next project going to be? People decided on data science, continuing with data science like NumPy, Pandas, and SciPy. So what can we build to continue on with our projects here? Anybody have any ideas? Hmm. I kind of want to think of something that also has some like personal, you know, merit as well. Because that's been something I've been doing on my projects is, personal. I think making an image for each variable would be cool if that was what you wanted. That's kind of that's a that's kind of cool because then you can do some data science where you use something like called game theory to determine the percentage of contribution to each factor put in, which resulted in the output. Interesting. And then you can use that data to make predictions, and that's where the AI stuff comes in. Hmm. I think fetching accurate data can be help determine what variables off or affected. So let's just put this idea on the back burner then. Like, what other ideas with data science related can we do? Like, in terms of like mass amounts of data, what can we do with mass amounts of data to visualize something or hmm. Hmm. Think. It's have to be our homework. Turtle. um. All right, you guys. Let's go ahead and brainstorm offline. There's something really much more easy. There's really some really much more easy projects though where you don't need any of post processing off the data you're describing. Yeah, I'll have to maybe just do some research on some, data science projects that have some sort of some sort of personal um, relation. So let's go ahead and take a break here. I appreciate you guys so much for being here and joining me tonight on May 6th. I know it was a little bit shorter of a stream today. I had a little bit longer day at work. I actually computed one of my chemical matrices today because I'm beginning to build one of my products that I build on a consistent basis about once every quarter. Um, and so oh, sorry, Orion. I'm so sorry, dude. It's awesome to have you here, though. I appreciate you for stopping in, though. Thank you so much, dude. Yeah, so I computed one of those today, and so I'm actually meeting on Thursday with a member of the bioinformatics team to start this process of actually automating this. I computed it by hand. It took me about 2 hours to come up with a proper key that I think will work based off some previous data and my own interpretations. And so yeah, it's pretty cool. Or at least that was what I did today. So I thought I'd let you guys know. Yeah, we'll have to keep going on the leak code. I'm just a little bit hoot for today. I did a lot of math and data processing. For the past few days, I've been just mass amounts of testing. I'm testing a bunch of serums for all of their constituents. So one serum might like test for a bunch of different things like protein, sodium, chloride, of all these different sensitive analytes, and I have to know the range of each analyte within the single serum. But if I have one lot of serum, let's say I have 20 lots of serum, well, I need to know each point across each lot of serum so that when I blend them together, I know what the predicted output will be of the blend. And so that's exactly what I'm computing in my with my matrices is I'm doing that by hand right now. And so I proposed to my group to let's I'm a programmer. I think I can do this if you get me some you know I think I can do this by if you give me some help and someone that maybe can help guide me in the right direction. So I was assigned a person from the bioinformatics team to where I'm going to work with, and we're going to build this. Um, it's going to be crazy. I will say, Tim, now, comparisons are obviously something you don't want to do, but in the corporate world, you sometimes have to, leverage your positions. But in terms of just like raw output, I will say I produce probably like on average like 2 to 2.5x relative to kind of some of my peers in terms of just like normally this amounts of data processing. So like 20 serums or 20 lots of serum across 20 analytes, right? Right? And then that's programming each test. That's making the individual dilution. So I have to take the serums. I have to make the 5 dilutions of the cereal, dilute each one of them to get ranges I can test then on the machines. And I was able to get about 95% of the data done in about 3 days. And in the past, some of my peers, it's taken them groups. I've been solo on this, which is people don't do this alone. I do this solo, and and people that do this in teams of like three take upwards of like a week to do about like 25 serums. So and I've done about 95% of these 20 serums in about 3 days. So I've been grinding. I just have really, really good time management. I just know exactly like how long the tests take, how long it takes to program. So while I have tests running, I know exactly what I need to do and when those tests will come out in the meantime. So like there just is no downtime. Like I'm just like boom, 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 boom. And so you know, I will attest like that's why like I'm 26. I started this job when I was 23. It's 2025. I started in 2022. Yeah, so 23, right? Um, you know, I already have a promotion. I'm a scientist too. I lead the big products, and so it's I put in a lot of work to try to like really understand the process and really try to like just and I'm pitching. I understand the process to the depth of the level where I'm trying to pitch automation of it, right? Improve. And a lot of my like older like coworkers, they kind of give me a lot of flack for this kind of project. At least at the start they were kind of like, I really don't think you should like waste your time with this. Or at least that's kind of like the vibe I picked up. And in my opinion, I kind of just I was a little bit like off put by it because it just kind of seemed a little bit funny. Like, why wouldn't you want to like at least try to make your life easier? Like, yeah, you might have tried and you might fail, but you would have learned something, and then you might be able to go off into another avenue and then try that, and then maybe you'll be successful down that avenue. But you'll never know if you don't try. So when I was coming to them saying, "Hey, I think like I'm a programmer. I think we can take all this hand calculation and interpretation and they have iPhones, they have AI, they have silicon chips. Like this technology that we're using is so outdated and so unoptimized. Using human interpretation in this day and age for this kind of math is just like. So I was like, I came to them and I was like, like, what are we doing here? Like, what we can definitely do this. And they were like, again, I don't think it's worth it. Like what's not broke, don't fix it. But and it was like, but it is broke in a way. Like there's room to drastically improve. Like some of like the like it like what I'm telling you is if Microsoft Excel went down, my line of business, my field, my product line would be gone. Like Microsoft Excel, like everything runs off of Excel, like for these types of things. That's how like dependent they are on it from back in like the 90s and 2000s. They haven't moved on to like any actual custom software for computing these things. It's all just Excel documents. Like it's just thousands of Excel documents. I won't lie, man. I got to that age where I low key realized why things like this don't change. You gotta have some young buck come in there and shake things up, I guess. Yeah, it's very much that kind of like that, you know, you know, it's not. I'm not trying. This is not ageism. This is not that at all. But it's very much like it seems like people that have been at like a place in a routine, especially at a company, and become very comfortable with like let's say their paycheck or whatever they are, you know, because at the end of the day, like it's life, and so they get caught up in just living life, and at the end of the day, they just get used to this paycheck and their job and their routine, and so they really don't want these drastic changes because then it requires them to have to come back into this world when they're like 30, 40, they have kids that are at soccer. They're just here to supply their family with resources, and so if when you try to come in there and throw curveballs, it can really start to like, whoa, what's going on? What's a DSL? Brass? You mind telling me? Thanks for coming in, dude. Anybody got to have any experience with that? Older coworkers and just not being very receptive to like new ideas and at least trying new ideas, you know, or at least just being like kind of a little bit blind to the point, thinking like it's impossible. Like we have people that go to space. It is not impossible to get a computer to compute this serum matrix or whatever. It's like domain specific language. What does that entail? I did have that experience and then became it. That's funny. AI probably means Allen Iverson. You know, I do think that when they do the employee rankings, I do think I rank pretty high on there. Just I'm very much like an all business kind of guy. Like I really just go to work and I really just try to get as much done as I can in the time I have there. You know, I you know, I'm not too social. Like I know it might seem like this on the stream, but in person I really like to keep to myself, put in my headphones and just grind. And and then next thing I know, 2 hours, 3 hours have gone by. Time for lunch. Eat my lunch. You know, chill out. Do a little bit of scrolling for 15 minutes. Grind, grind. Take a little break. Go outside. Walk around for a second. Get some sun. Go back. Headphones. Grind. Done. Like that's just how I kind of like to do it. And you know, I have gotten it in the past at some jobs that I've been kind of like unapproachable. When I was younger, people thought that I was like mad or something, but I was just kind of focused. Like when I used to work at like pizza places. But no, I've gotten a lot better about just not like when I'm focused. Just like I look pretty intense, but I'm trying to just like solve problems. You can probably see on the leak codes and stuff. Well, first of all, unks with 30 years experience won't even listen to an idea from an intern. Depending on how it's built, it may be useful for an application. Basically, the time sink and cost to build something new is equivalent or greater to end result or just doing things the way it's done now. When you're higher up, you have to justify the other senior position members why you're taking the team in direction in relation to the cost of your budget. That's all it effectively is. You spend time risking to lower your outputs for a while for a greater reward later, all while you need to make money. Yeah, dude, it's that corporate game. Exactly. You hit it right on the head. It's kind of like that, like I talked about the other day, that NBA circle jerk. It was funny. I was watching a Prime video, and he was talking about the NBA circle jerk in his reaction video, and it hit it right on the head. How, yeah, I guess they do have to, weigh those budget options, but the fact that those budget options are even there because in reality, their salary is option, a budget option. How did you meet Madame Demi? Dude, I met my girlfriend in college. We worked together at a restaurant. When I was just, before I kind of got into all this, I was more um, just in school, kind of more freeloading, just living life, kind of experiencing stuff and circle jerks. Not Tim. I think that's enough on that one. Yeah, I hate it when coworkers find it annoying just because you're more independent. Like I'm just there to work and go. Yeah, Marty, that's kind of how I'm very very friendly. I'm very receptive to people when they ask me questions and everything. But when I'm really there just to get the work done. And at the end of the day, a lot of your coworkers too. You'll never see them again too. So when you leave, it's kind of just the reality of how things are sometimes. End up becoming that resistant to change person. Yeah, that's funny, dude. That's exactly it. Make a simple plug and go language slash framework that non-programmers may be able to use. Yeah, Brass, that's exactly what we're going to work on here for um, this project that I'm going to meet with that bioinformatics guy this week, and we're going to go over it. So it's going to be super cool. It should be fun, and I'll let you guys know how it goes. The experiences I get. If you guys are part of the late night stream, leave a like on the stream. It really, really helps. There's 12 people here watching on the YouTube. please, if you guys could, just throw a like. It really, it's free and it just helps YouTube to keep pushing our stuff out. All right, you guys. It was fun talking to you. I enjoyed talking to you guys these last like 15 minutes, just kind of about stuff. I really appreciate you guys being here on May 6th. We watched this one. I know this today was a little bit slower. It's more of kind of like a detox day after we released our project yesterday. We kind of were on like that project high, and now we're like, woo, kind of like on the down slope as like, now what? You kind of get that where you're like, oh, project is almost done, boom, and it's done. And then you're like, okay, now I just need so tomorrow we'll pick things up. We watched one episode of the Corey Schaefer videos here of the Panda series that we are watching. We watched episode 4. Tomorrow we'll watch episode 5 out of 10, I believe there are. So far, so good. Pandas is pretty easy and pretty simple. Similar to the other kind of data structures stuff we've looked at, or database stuff we looked at with SQL, but just in its own way here of actually kind of using more Python related syntax, or coding related syntax rather than verb or verbage related syntax, wordage. So I appreciate you guys being here and joining me. I'll see you guys tomorrow. Please join the Discord link down below and chat with me there. It's awesome to guys have you guys here, and I'll see you guys then.